Hi guys, welcome back to Meritstore. Today we're going to be discussing some past questions from the chapter section Midpoint and Centroid Formula. In the previous video, we've already discussed the important formulae, the concepts that could come from this topic. I'm going to put the link of the video in the description. You can check that before going ahead with the sums. So get your paper and pen ready, start making notes, and we'll check the video.
This is a question from 2020 paper. Find the ratio in which the line joining -2, 5 and -5, -6 are divided by line y is equal to -3. I have to also find the point of intersection. Two things to find here, ratio and the point of intersection. So let's take the line here, A and B. I'm taking this line AB. -2, 5, that becomes x1, y1. And -5, -6, x2, y2. It's divided by the line y is equal to -3. So let's take that here, P. And it's y is equal to -3. That means x is some value, but y is -3. I need to first find the ratio m is to n. We're going to use the section formula, and since I know the y, I'm going to use the y formula. So formula is y is equal to m y2 plus n y1 upon m plus n. In place of y, I'm going to write -3. -3 is equal to m y2. y2 is -6. So -6 plus n and y1 is 5. So 5 upon m plus n. We'll take m plus n on the other side here. So it becomes -3 m plus n is equal to -6m plus 5n. This becomes -3m minus 3n. We open the bracket. Now, I'm going to take this to the right hand side and this to the left hand side. So my equation further looks like -3n minus 5n is equal to -6m plus 3n. This becomes -8n and this becomes -3m. So I need the ratio as m upon n. So 8 remains here as it is, 3 comes down. Negative signs cancel. So the ratio m is to n will be 8 upon 3. That's the ratio. We've got the first thing. Now I need to find the point of intersection. That means I need to find the x and y value. Y I already know, it's -3. Let's find the x value using the ratio 8 upon 3. And let's use the x formula here. So the x formula would be m x2 plus n x1 upon m plus n. Now m is 8 and n is 3. x2 is -5 and x1 is -2. So I'm going to use that here. So 8 into -5 plus 3 into -2 upon 8 plus 3. That becomes -40 minus 6 upon 11. That becomes -46 upon 11. So the point of intersection, for that point, the coordinates are -46 upon 11 and -3. That's our answer. Okay. Here we have the next question, which is from 2019. It says m and n are the 2 points on x-axis and y-axis respectively. P divides the line segment mn in the ratio 2:3. Find the coordinates of m and n. So let's draw our x-axis and y-axis. This is y. I'm going to draw x here. M, they're saying it's on x-axis, so m should be here on the x-axis and n is on y-axis, it's written. So a line like this. This will be n and this will be m. And there's a point here P, which is dividing mn in the ratio 2:3. You see mn, so m here will be 2 and this here will be 3. We have to find the coordinates of m and n. Here I have a question from 2019. M and N are 2 points on x and y axis, and P is a line that divides MN in the ratio 2:3. So let's just draw a rough x and y axis. So this is y axis, this is x axis, and I have MN, line MN. So that will be like something like this. M is on x axis, so this is x, so this should be M, and then should be here. Point P is somewhere here, which is 3, 2, point P. And it's dividing MN in the ratio 2:3. So M part is 2 and the N part becomes 3. Now if this point is on the x-axis, that means the y is 0 and there's some value for the x. And if this point is on y-axis, that means x is 0 and you have some value for the y. So that's the coordinates what we have got. So this becomes x1, y1. This is x and y. This becomes x2, y2. So let's start solving. So this is x and y. This is x1, y1. This is x2, y2. So let's start solving. Let's do for the x1 first. X is equal to mx2 plus nx1 upon m plus n. So your x is 3. So 3 is equal to m is 2. So 2 into 0 plus n is 3. So 3 and x1 is here x. 3 plus 2. So that becomes 3 is equal to 0 plus 3x upon 5. So this would become 15. 15 is equal to 3x. 15 upon 3 is equal to x. X is equal to 5. We've got that. So x is 5. So here m point will be 5, 0. Let's do for the y1 now. So y is equal to m y2 plus n y1 upon m plus n. Your y we have 2. So 2 is equal to 2 into y2 is y plus n is 3 and y1 is 0 upon 2 plus 3 is 5. Here it becomes 10. 10 is equal to 2y plus 0. 10 upon 2 is equal to y. 5 is equal to y. So here this was for n. So the n coordinate becomes 0, 5. That's our answer. Here I have a question in which it's written P is 1, minus 7. It's a point on the line segment AB. And it divides the line AB in the ratio AP is to PB, 2 is to 3. So let's take this as a line A and B here. This is P, this is 2 and this is 3. So this is 3, 6 minus 6 and this is 1, minus 7 and this is x and y. For timing, I'm going to take this as x1, y1, this as x and y and this as x2, y2. We'll later on resubstitute that. So we're going to use the section formula. X is equal to m x2 plus n x1 upon m plus n. X is given as 1, m is 2. So 2 into x2. So 2 into x plus n is 3. x1 is 3 here upon m plus n. 2 plus 3 is 5. So 5 goes here. We multiply. 5 is equal to 2x plus 9. 9 goes on the other side. 5 minus 9 is equal to 2x. Minus 4 is equal to 2x. And x is equal to minus 2. Similarly, we'll use the y formula. Y is equal to my2 plus ny1 upon m plus n. Y here is minus 7. So minus 7 is equal to m is 2. So 2 into y plus 3 into minus 6 upon 5. 5 goes on the other side. It becomes like this. 2y minus 18. So this is minus 35. 18 goes to the other side. Minus becomes positive. 2y. Minus 35 plus 18. That gives me minus 17. 2y. So y becomes minus 17 upon 2. So the coordinate for B will be -2 comma -17 upon 2. That's our answer. Here we have a question which says calculate the ratio in which the line joining A and B is divided by the point P. I have to find X and I have to find the length of AB. So this becomes X1, Y1, this becomes X2, Y2, and here P is X and Y. Since I know the value of Y, I'm going to use the Y formula only to find the ratio first and then the value for X. So Y is equal to my2 plus ny1 upon m plus n. Y is 3. So 3 is equal to m2 is 6. So y2 is 6. So 6m plus y1 is 2. So 2n upon m plus n. M and n goes to the other side. It becomes 3m plus 3n is equal to 6m plus 2n. I take m on the other side, so 6m minus 3m, and 2 will go to the left hand side, so 3n minus 2n. This gives me n is equal to 3m, so the ratio would become m upon n would become 1 upon 3. Using this, we're going to find the coordinate of P, the x coordinate which is missing. So x is equal to m x2 plus n x1 upon m plus n. X becomes, we leave x as x. M is 1, so 1 into x2 is 3 here, plus n is 3, and x1 is minus 4, and 1 plus 3. So x is equal to 3 minus 12 upon 4. That gives me minus 9 upon 4. X is equal to minus 9 upon 4. So here the coordinate for P is minus 9 upon 4 comma 3. That's the first part of the answer. We have to find the distance between AP. So A we take it as x1, y1, and P we'll take it as x2, y2. So the distance formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now x2 is minus 9 upon 4, x1 is minus 4, so it becomes minus 4 here, the whole square, plus y2 is 3, so 3 minus 2 the whole square inside the root. So this part is pretty simple. That gives me 1. Let's do this part here. So minus 9 upon 4 minus 4. That becomes minus 9 upon 4 plus 4. I need to take the LCM. So into 4, there's nothing below, so 1 into 4. We'll multiply both numerator and denominator by 4. I get 9 upon 4 plus 16 upon 4. Now I can carry out the calculation. This would become 7 upon 4. So here I have 7 upon 4 the whole square. This comes up to be 49 upon 16 plus 1 the whole square. Again LCM. So 49 plus 16 upon 16 the whole square. That will be 5, 1 carry over 65. 65 upon 16 the whole square. I don't have a perfect square for 65. I can leave the answer here like this or like this. 16 has a perfect square, so that becomes 4. Both the answers are correct. So the distance between AP is root 65 upon 4. So here the question is, AB is the diameter of the circle with center C. And C is minus 2 comma 5, A is 3 comma minus 7. I have to find the length of radius AC and I have to find the coordinate of P. Now if C is the center, that means C is the midpoint for the diameter AB. And so let's take this as x1, y1, this as x and y, and B as x2, y2. So we'll be using the midpoint formula. X is equal to x1 plus x2 upon 2. Here x is minus 2, x1 is 3, and I don't know x2 upon 2. So 2 goes on the other side. It becomes minus 2 into 2 is equal to 3 plus x2. Minus 4 is equal to 3 plus x2. Minus 4 minus 3 is equal to x2. Minus 7 is equal to x2. We've got the x. Y. So y1 plus y2 upon 2. Y is 5. So 5 is equal to y1 is minus 7 plus y2 upon 2. 2 goes on the other side. So it's 10 is equal to minus 7 plus y2. 10 plus 7 is equal to y2. 17 is equal to y2. So the coordinate for B is minus 7, comma 17. That's the first part of the answer. The coordinates. Then they're asking us length AC. So we'll have to use the distance formula to find length AC. So A is 3 comma minus 7, that's x1, y1, and C is minus 2 comma 5, that I'm taking as x2, y2. As per the distance formula, it's x2 minus x1 the whole square plus y2 minus y1 the whole square. So the formula would become x2 minus x1 the whole square plus y2 minus y1 the whole square. X2 here is minus 2. So minus 2 minus 3 the whole square plus y2 is 5. y2 5 minus minus 7 the whole square inside the root. Here minus 2 and minus 3 both are negative. So I get minus 5. Minus 5 square will be positive 25. So I'm writing 25. 5 minus minus 7. So that becomes 5 plus 7. There are two minus sign in the center. So it becomes 5 plus 7. That's 13. That's 12. 12 square is 144. This becomes root 169 and root 169 is 30. So the length of radius AC is 13 units. So here I have a question. ABC is a triangle. G, which is a centroid of the triangle. I have point A, B, and C. There are certain points missing in point B and point C. We have to find that, and we have to find the length of BC. So I'm going to take the centroid as x and y. I'm going to take A as x1, y1, B as x2, y2, and C as x3, y3. So according to the centroid formula, x is equal to x1 plus x2 plus x3 upon 3. So x1, x is 4. x1 is 1, x2 is 4, and x3 is 8 upon 3. This goes on the other side. So 12 is equal to 5 plus 8. 12 minus 5 is equal to 8. 7 is equal to 8. We do for y. Y is equal to y1 plus y2 plus y3 upon 3. Y we have it as 3. So 3 is equal to 3 plus b plus 1 upon 3. 3 goes on the other side. So 3 into 3, 9. And 3 plus 1 is 4. So 4 plus b. 4 goes on the other side. 9 minus 4 is equal to b. 5 is equal to b. So we found the first thing, A and B. A is 7 and B is 5. Now, length of side BC. For that, I need to use the distance formula. So B here is 4, comma, B is 5. 4, comma 5, and C is 7, comma 1. This is x1, y1, x2, y2. So x2 minus x1 the whole square plus y2 minus y1 the whole square. The formula. x2 is 7, x1 is 4. 7 minus 4 the whole square plus y2 is 1 and y1 is 5. 1 minus 5 the whole square. Now 7 minus 4 is 3. 3 square is 9. 1 minus 5 is minus 4. Minus 4 square becomes positive 16. This goes up to 25. Square root of 25 is 5. So the length of side BC is 5 units. That's our answer. Here we have that the midpoint of a line segment joining this and this is this. So this is the midpoint. I have to find the value of A and B. So let's take this as x1, this one y1, minus 2 as x2, and 2b as y2. This is the midpoint, so this is x and this is y. According to the midpoint formula, x is equal to x1 plus x2 upon 2. x1 is 2a and x2 is minus 2 upon 2. And our x is 1. The 2 goes on the other side, it becomes 2. So 2 is equal to 2a minus 2. This 2 also goes on the other side, so it becomes plus 2. 2 plus 2 is equal to 2a. 4 is equal to 2a. A is equal to 2. We got the value for a. Now for b, we'll use the y midpoint formula. Y is equal to y1 plus y2 upon 2. Y is 2a plus 1. y1 is 4, y2 is 2b upon 2. Now, we'll take 2 on the other side. So, 2 multiplied by 2a plus 1 is equal to 4 plus 2b. 2 into 2a, 4a, 2 into 1 is 2, 4 plus 2b. Now, we've got the value of a in our previous solution here as 2. So, I'm going to substitute this as 2. So 4 into 2 will become 8. 8 plus 2, and this also comes the other side. So minus 4 is equal to 2b. 8 plus 2 is 10. 10 minus 4 is 6. 6 is equal to 2b. B is equal to 3. So A value is 2. B value is 3. That's the answer. Here I have the last question. Here I have a question which says, find the coordinates of the centroid of the triangle whose vertexes A, B, and C. Simple. This is x1, y1, this is x2, y2, and this. Here we have to find the coordinates of the centroid of the triangle A, B, and C whose points are given here. I'm taking A as x1, y1, B as x2, y2, and C as x3, y3. So the coordinate centroid formula is x is equal to x1 plus x2 plus x3 upon 3. So that becomes minus 1 plus 1 plus 5 upon 3. So 1 and 1, minus 1 and 1 becomes 0. So it's 5 by 3. Y coordinate can be found out by y1 plus y2 plus y3 upon 3. y1 is 3, y2 is minus 1, and y3 is plus 1 upon 3 again. So this becomes 0, 3 upon 3, that becomes 1. So the centroid coordinates are 5, 3, and 1. That's our answer. Here it's given that the consecutive vertices of a parallelogram ABCD. ABC is given. I have to find the fourth vertex D. So if this is my parallelogram, let's take this for example, A, B, C, and D. A is given 1, 2, B is given 1, 0, C is given 4, 0. I have to find D. So let's first number the points. x1, y1, x2, y2. This becomes x3, y3, and this is x4, y4. The property of a parallelogram is that the diagonals bisect each other. Bisect each other. That means the diagonals will meet at a point. Let's say this P, and this P becomes the midpoint. So P is midpoint of BD, and P is also a midpoint of AC. So the midpoint P will be common for both diagonal BD and AC. So let's find out the midpoint for AC, because we have A points and C points. Let's find out that. X is equal to x1 plus x3 upon 2. x1 is 1, so 1 plus 4 upon 2. That makes it 5 upon 2. So x is 5 upon 2. Y becomes 2 plus 0 upon 2. So y is 1. Now this x and y is equal. Now this is the midpoint for P. For P here, 5, 2 and 1. This is equal for, which is equal to the midpoint of BD as well. So when I do for BD, B is x2. So x2 plus x4 upon 2, that's equal to 5 upon 2. So 5 upon 2 is equal to x2 is 1. I don't know x4, and this is 2. 2 goes on the other side. I get 5 by 2 into 2 is equal to 1 plus x4. 2 and 2 cancel. 5 minus 1 is equal to x4. So this is 4. I got the x value for t. Similarly, we'll do for y. That's 1 is equal to y2 is 0. So 0 plus y4 upon 2. 2 goes on the other side. So 2 is equal to 0 plus y4. 2 is equal to y4. So the vertices of the fourth, the coordinates of the fourth vertices, D, is 4, 2. That's our answer.